Hello, Latin geometry students. In this assignment, we're going to talk in a little bit more detail about mid-segments. Those are segments in the middle of a triangle, but a specific type of segment. See, to make a mid-segment, what we do is we start off with a triangle, and then normally you would take your ruler and find the middle of each side, the point we call the midpoint. To create a mid-segment, we simply connect the midpoints up through the sides. Here, I'm going to draw in all three of them at the same time, and each of these three is a mid-segment. And we're going to talk about some of the rules for mid-segments. The first rule that we need to know is that each mid-segment is parallel to one of the sides of the triangle. Here we have the mid-segment and the bottom highlighted. Those two sides have to be parallel to each other. The bottom couldn't be parallel to one of the other sides. It's touching both the other ones. But the one side that's not touching it is actually parallel to it. Each mid-segment is parallel to one side. Here in this case, these two are parallel to each other. And these two are parallel to each other. The mid-segment is always parallel to one side in the triangle. All right. Our triangle, by drawing in all the mid-segments, we create four little miniature triangles. But they're not just little miniature triangles. Each one is a dilation of the original triangle. Each one is a little triangle that's half the size of the original one, but it's still the exact same shape. All right. Now, the rule that we're going to spend most of our time on is talking about the length of a mid-segment and its parallel side. Here, we have the length of a mid-segment. Its length is 10, and the side it's parallel to has a length of 20. Those two numbers have a really simple and obvious connection, and yes, it is exactly what you think it is. The mid-segment is half the length of its parallel side. Can be a little confusing for people. Let me take it to a real-world example, and so you can see this, and maybe it'll make a little sense as to why. This is the Luxor Hotel and Resort in Las Vegas, Nevada. It's a cool hotel. It's shaped like a pyramid. It's got a big Egyptian theme. It's got pools and all sorts of other cool stuff in here. Now, I know this is a pyramid, but the side of the pyramid is a triangle, so a lot of the same rules are going to apply here. So we're just looking at one side of it, just this triangle. If this is the bottom of the triangle, this is the floor where you first walk into the hotel. And then all through this hotel, there's all sorts of other floors. Let's talk about the mid-segment, which would be the floor halfway up. This floor, I'm going to guess it's like the 10th floor. Maybe it's a 20-story pyramid. The ground level and this floor have to be parallel. They both got to be level to the ground. You don't want one of the floors to be slanted. That way, every time you drop something, it rolls away from you. They have to be parallel, and they're both parallel to the ground, so nothing rolls away. But not only that, the rule we're talking about with lengths will apply too. See, if we say the bottom of the pyramid is 400 feet, I don't know if that's true, I just made up a number. The top of the pyramid, if you went all the way at the top, its distance is literally 0. So how wide is the floor that's halfway up? Well, it's going to be halfway between 400 and 0. You could add them up and average them, but there's no need to do that. It's always going to turn out to be 1/2 of that. This floor will be 200 feet, half the length of the bottom, because it's halfway up the pyramid. So we see this in problems like this. If we know the length of the mid-segment, in this case is 7, then its parallel side is going to be double that, 14. Or if this mid-segment is 3, its parallel side is going to be double that, 6. So let's take a look at some of the problems that come with mid-segments. First off, this line, or segment, pardon me, through the middle of the triangle, we have to confirm that it is a mid-segment. And it is, because if you look at the markings on the side, this little part of the triangle is the same as this little part. So these two sides, these two parts of this side are the same. That means this is the middle, or it's the midpoint. Same over on the other side of the triangle. This side, or this part of the left side and this part of the left side are marked the same. That means this point must be the middle. It's the midpoint. Connecting the midpoints, we have a mid-segment. So we know that this segment, X, here represents the length of the mid-segment, and the side it's parallel to is the 34. These two are connected to each other because they're parallel to one another. Now, everybody's first instinct is to say, oh, okay, I get it. So the mid-segment will simply be half this length. There is absolutely nothing wrong with doing it that way, except when the problems get a little bit harder, it'll make more sense to think of it as the other way. What I mean by that is instead of taking 34 divided by 2 to get the length of the mid-segment, what you really want to do is think of the mid-segment times 2 would give you the length of the side. This will make the harder problems easier, though you don't really have to do it in this problem. But if we do it this way, we take the length of the midsegment and double it, then that's equal to this side. So 2 times x is equal to 34, and then simply solve that equation. It's an easy equation to solve. We just divide both sides by 2, and we'll get 17 for the length of the midsegment. We should be able to do these problems the other way. Like, for example, if you were given the length of the midsegment, you should be able to find the length of the side, like this problem. So take a second. The best way to do this problem is to think of taking the midsegment and doubling it, and that's the length of the side. So 34 times 2 would give us x, and x is going to turn out to be 68. Now, as we get slightly more difficult problems, it will make sense why we're doing it this way. For example, this problem. Now, again, a lot of people's instinct will be to say, hey, I'm going to take 54 and divide it by 2. That can help you get to the right answer, but as the problems get harder, it'll be easier to think of it as, I'm going to take the 3x and double that and make that equal to 54. So we take the length of the midsegment, 3x, double it, and make that equal to 54 and solve that equation. In this case, we have 2 times 3x equals 54. That's 6x is equal to 54, and then divide by 6, we'll get x is 9. Let's try that again for another of these medium level problems, and then we'll get to the hard ones. Take a moment, see if you can find x. Okay, we have the two sides we care about. We have this midsegment and the side it's parallel to. We know if we take the length of the midsegment and double it, we'll get the length of the side. So we're looking at 10 times 2 is equal to 5x, and then solving that equation. 10 times 2 is going to be 20. So we have 20 is equal to 5x, and then divide by 5, and we'll get 4. Okay, now we're going to look at the hard versions of this problem, where in the problems we've done so far, if you've had a shortcut, that shortcut might not work very well in the next couple. So in this problem, it's a little bit harder to take the x plus 9 and divide it by 2. That can make this problem hard, which is why when we're looking at these two sides, again, it'll be easier to take the length of the midsegment and double that and make that equal to the x plus 9, the length of the side. So for this problem, you want to take 2x, double it, and set that equal to x plus 9, and then solve for x. If you do that correctly, you get 2 times 2x is equal to x plus 9. We simplify on the left side and have 4x is equal to x plus 9. The rest of the algebra, we're simply going to subtract x from both sides, and then divide by 3. We'll get x is equal to 3. Let's try that again. One more hard problem here. Start with this one. You're going to take a minute and try to solve for x. Start by trying to figure out what the equation is. We double the midsegment and set that equal to the side. Okay, so our two segment lengths that we care about, the midsegment 3x and the 4x plus 20, what we want to do is double the 3x and set that equal to the length of the side, 4x plus 20. So we're going to have 3x times 2, that'll be 6x, is equal to 4x plus 20. And take a moment and solve that equation. If you do that properly, very quickly we're going to have 6x is equal to 4x plus 20. Then we subtract 4x from both sides, and we'll have 2x is equal to 20. Divide by 2, and we get x is equal to 10. This is the common kind of difficult problem that we run into with midsegments.